welcome to Cambridge Chemistry. Welcome back to the crash revision of 5070 syllabus. Uh, Alloy and their properties. Now describe an alloy as a mixture of. This is the definition of beta. This is definition of alloy. Alloy is as a mixture of metals with other elements, including like bronze is a alloy as a mixture of copper and zinc. This is metal and this is metal. It means mixture of metals, mixtures of metals, and stainless steel as a mixture of iron and other elements such as chromium, nickel and carbon. So this is the mixture of other elements, metals with other elements. This is metals, but this is non-metals. Okay, so alloy is a mixture of metals and metals with other elements like chromium, nickel, carbon and non-metal like carbon. Explain in terms of structure how alloys can be harder and stronger than the pure metals, because this is the reason. So he has given the reading in syllabus content why alloys can be harder and stronger than the pure metal, because the different size atoms. So this is the structure of alloy. This is the different size of atoms which prevent the layers to slide over each other. And metal is a regular layers of atoms which slide over each other. Okay. This is the difference. This is alloy structure and this is metal structure. Different size atoms are ions in alloys mean the layers can no longer slide over each other. So mixing of other metals prevent the layers to slide over each other. So that's why alloys can be harder and stronger than the pure metals. Describe the uses of alloys in terms of their physical properties, including stainless steel in cutlery. This is very important, which is given in the syllabus content. That point is very important. So you should learn that the physical properties including stainless steel in cutlery because of its hardness and resistant to rusting. This is very important to learn, that why what is explain the physical properties in context of hardness. So it is stainless steel in cutlery because of its hardness and resistance to rusting. Identify representations of alloys from diagrams of. This is the alloy structure, this is alloy structure, and this is metal, this is metal structure. I have drawn earlier in metallic bond. This is metal structure, this is positive metal ion, and this is C of delocalized valence shell electron. Reactivity state, the order of reactivity series as potassium, sodium, calcium, magnesium. You are very well aware of reactivity series. So potassium coming first, then sodium, calcium, magnesium, aluminium, carbon, zinc, iron, hydrogen, copper, silver and gold. So this is the reactivity series. Describe the relative reactivities of metals in terms of their tendency to form positive. Highly reactive metals readily form positive ions by displacement reaction, positive ions by displacement if any with the aqueous ions of magnesium, zinc, iron, copper and silver. For example, if magnesium react with zinc sulfate, can displace because magnesium is more reactive, magnesium sulfate and zinc, silvery zinc. If iron react with copper 2 sulfate, FeSO4 solution turn, this is blue solution, and FeSO4 is green solution. This is green solution. Blue solution turns green plus copper solid, pink solid. There's two observations. Blue solution turn green and pink solid appears. This is again, this is another. These are the displacement of highly reactive metal displace less reactive metal from its solution. So this is aqueous, this is aqueous, this is aqueous, this is solid, this is solid, this is solid, and ionic equation of this reaction is magnesium solid plus zinc ion 2 positive, or magnesium 2 positive and zinc solid. Similarly, iron Fe solid plus Cu2 positive to form Fe2 positive to form Cu solid. These are the ionic equation of these reactions. Potassium, describe the reaction of, if any, of potassium, sodium and calcium with cold water. So these are the reactions, very important. You should learn these reactions by heart. Potassium with cold water. Potassium react with water to form potassium hydroxide plus H2, 2K, 2K or 2H2. Similarly, sodium, similar reaction, H2O plus 2 NaOH plus hydrogen gas. Similarly, calcium with cold water plus H2O to form calcium hydroxide plus hydrogen gas. So this is the reaction of with cold water. These three metals only react with cold water. Keep it in mind. And effervescence of gas, solid dissolves. This observation of these reactions are: observation is solid disappears, effervescence of hydrogen gas, H2 gas. Magnesium with steam, this reaction is also very important. So now only magnesium with steam. You should know magnesium with steam. Magnesium react with steam H2O in the form of gas to form magnesium oxide plus H2 gas. Magnesium, zinc, iron, copper, silver and gold with dilute acid. So only magnesium, zinc and iron react with dilute acid. These metals are less reactive, so cannot react with dilute acids. So only magnesium, zinc, iron, like magnesium react with dilute HCl to form magnesium chloride plus H2. Zinc react with HCl to form zinc chloride plus H2 gas. Similarly, iron, the same reaction, 2 over here, 2 over here. Explain this reaction in terms of the position of metals. These are moderate reactive metals. Only these metals react with dilute acids. Magnesium producing more bubbles of gas, zinc less than magnesium, iron less than zinc. Explain the apparent unreactivity of aluminium in terms of its oxide layer. Aluminium, even though aluminium is placed above in the reactivity series, but it is less reactive due to the oxide layer. Oxide layer which is non-porous, so does not attacked by water and acids. Deduce the order of reactivity from given set of experimental results. For example, HCl if experimental is set up, because this is very important in ATP point of view. So the reactivity, for example, reaction of these metal with cold water and reaction of especially magnesium, zinc and iron with dilute acid are very important. With magnesium more bubbles of gas, with zinc less bubbles than magnesium and less bubbles than zinc and magnesium. Corrosion of metal states the condition required for the rusting of iron and steel to form hydrated iron 3 oxide. The, the conditions are air, oxygen and water. These are the two conditions. Describe, and the reaction is like this: iron plus oxygen to form plus water to form iron 3 oxide Fe2O3 dot H2O. So this is 2Fe3 4 2 and hydrogen is, if we write down 2 over here, 2H2 2 2H2 2 4s are 8. Now This is over here place 2. This is rust 4Fe, and 2 3 is 6 and 2 8, and 2 over here, and 2 and 3 2 is 6. So this is the reaction. This is rust. This is the formula of rust, iron 3 oxide, hydrated iron 3 oxide. Describe how barrier methods prevent rusting by excluding oxygen or water, by using paint, by using oil, paint, oiling, and greasing. So prevent the iron layer from rusting. State some common barrier methods including painting, greasing. This is the common method. Coating and plastic. So this become barrier of rusting. Because painting, greasing, and coating with plastic prevent the iron from rusting. So you should know in this context all these content. Explain sacrificial protection in terms of reactivity series. In terms highly reactive metals like zinc and magnesium prevent iron from rusting. Describe the use of zinc in galvanizing. Coating of zinc. So zinc is more reactive than iron, so react earlier with moist air than iron. Hence, in this way, it prevent iron from rusting. Similarly, magnesium also used method and sacrificial protection. So zinc and magnesium used as a sacrificial protection. Extraction of metal. Describe the ease of obtaining metal from their ore related to the position of the metal in the reactivity series. The lower, less reactive metal compounds. Uh, Obtaining metals from less reactive metals is very easy because they are unstable and easily decomposed into metal or metal oxide, and metal oxide are further reduced with the different with carbon or carbon monoxide. Describe the extraction of iron from hematite in the blast furnace, including symbol equation for each step limited to burning of carbon to provide heat and produce carbon dioxide. This is reaction of this content, carbon dioxide, reduction of carbon dioxide to carbon monoxide, carbon dioxide plus carbon to form carbon monoxide, reduction of iron 3 oxide by carbon monoxide, Fe2O3 plus carbon monoxide to form Fe plus CO2, 2Fe, 3CO, 3CO2. Thermal decomposition of calcium carbonate, limestone to Brody. These are the steps of extraction of iron in blast furnace. And thermal decomposition of calcium carbonate, CaCO3 to form calcium oxide plus CO2, and forming slag, calcium oxide plus silica to form slag, CaSiO3. So describe the extraction of aluminium from purified bauxite. Bauxite ore is Al2 purification. Describe the extraction of aluminium from purified aluminium oxide. Aluminium oxide is Al2O3 and bauxite ore is Al2O3.Fe2O3. This is the bauxite ore, and cryolite formula is Na3AlF6. This is cryolite. The role of cryolite is used to lower the melting point, lower the melting point of alumina. Aluminium oxide, Al2O3. Why carbon needs? Because carbon rods burn, so hence for continuation of the process, carbon rods are periodically replaced after regular interval of time. Because carbon anodes get burned because oxygen is produced at the anode. So this is the extraction of iron. This is the process. These are the carbon rods. These are the carbon rods. positive terminal, negative terminal. Tank lining act as a cathode, which is made up of graphite. This is graphite cathode, and this is carbon rods anode. So at anode, reaction is 2 oxide ion to form oxygen gas plus 4 electron. So oxygen gas is produced at anode, so that's why anode rods get burned, hence periodically replaced after regular interval of time. So this is also very important. The reaction at cathode, this is the reaction at cathode. Aluminium 3 positive gains 3 electron to form aluminium liquid. So these are the reaction at cathode and anode of extraction of aluminium. And aluminium oxide and cryolite as a electrolyte plus Na3Al6. Cryolite is used to lower the melting point, or used as a solvent, or used to lower the melting point, used as a solvent. Okay, so these 2 points are very important. Is next topic is water. Describe chemical test for the presence of water using anhydrous cobalt 2 chloride and anhydrous copper 2 sulfate. Cobalt 2 chloride COCl2 with addition of water. This is anhydrous salt. Anhydrous salt is when we add water. This is from hydrated salt COCl2.6H2O, and this is reversible reaction. This is hydrated, and this is blue color, and this is changes into pink. Hydrated is pink. Similarly, copper CuSO4 is white in color, anhydrous, plus water. If we add water in copper sulfate, this is also reversible reaction, and it turns blue. White to blue. Hydrated is white. Salt with water molecule is hydrated, and salt without water molecule is anhydrous. Describe how to test for purity of water using melting point and boiling point, because pure water is 0 degree centigrade melting point and 100 degrees centigrade is it melts at 0 degrees centigrade and boil it. So that's why it shows that water is pure if water shows 0 degrees centigrade melting point and 100 degrees centigrade boiling point. Explain that distilled water is used in practical chemistry rather than tap water because it contains fewer chemical impurities. State the water from natural sources may contain substances including dissolved oxygen, metal compounds, plastics, sewage, harmful microbes, nitrates from fertilizers, phosphate. These are the substances which dissolve in water. State that some of these substances are beneficial, including dissolved oxygen for aquatic life, for respiration, for and some metal compounds provide essential minerals for life, and state that some of these substances are potentially harmful, including some metal compounds are toxic like mercury cyanide. Some plastics are harm aquatic life. Sewage contains harmful microbes which causes diseases like bacteria. These are the bacteria which causes different types of disease, waterborne diseases. So it contains domestic waste contains harmful microbes which cause disease. Nitrates and phosphates led to deoxygenation of water, and damage to aquatic life. This is known as eutrophication, and details of eutrophication process are not required. This is very important. 1 mark question will come or might be coming. Eutrophication, if this is coming, and this is the definition: unintentional growth of algal plants due to excessive use of fertilizers. So details of eutrophication process are not required now. For 23, 24, 25. Describe the treatment of the domestic water supply in terms of sedimentation, filtration to remove solid, and use of carbon to remove taste and odor, and chlorination to kill. These are the 3 methods which are very important to purification of water. Treatment of domestic water supply in terms of sedimentation: allow the water sedimentation, allow the waters to stand for some times in large container, and with addition of aluminum sulfate, settling agent which coagulate solids and allow solids to settle down in the bottom. Then filtration, filter the water to remove these solids. Then add carbon in the filter beds which remove taste and odor, and chlorine. Afterwards, chlorine, appropriate amount of chlorine is used to kill the germs in water. Fertilizers state that ammonium salts and nitrates are used as fertilizers, and these are very important for healthy plant growth. Why ammonium salts and nitrate used as for fertilizer? For healthy growth. For healthy growth. Describe the use of NPK: N for nitrogen, P for phosphorus, and K for potassium. The source of potassium is potassium chloride. Phosphorus is phosphate, ammonium phosphate, and domestic waste, yeah, or detergent as well. And nitrogen source is ammonium salts. So these are used for healthy plant growth. Next, air and quality and climate. So state the composition of clean dry air. As a proxy should know, 78% nitrogen, 21% oxygen, and remainder as mixture of noble gases. 1% is noble gases argon, and carbon dioxide is 0.03%. So this is the composition of, you should learn this composition of air. State the source of which is the no fractional distillation of air is right now in syllabus. State the source of each of these plate. No need to learn the fractional distillation. Carbon dioxide from the complete combustion of carbon containing fuel. This is the source of carbon dioxide. This is source of carbon monoxide and particulates from incomplete combustion. Particulates means solid carbon and CXHY, unburnt hydrocarbon. Combustion of carbon containing fuels: methane from the decomposition of vegetation, and waste gases from digestion in animals. Oxides of nitrogen from car engines, sulfur dioxide from combustion of fossil fuels which contain sulfur compounds. These are the sources of these pollutants. State the adverse effect of these air pollutants. Carbon dioxide, higher level of carbon dioxide leading to increased global warming which leads to the climate change. Carbon monoxide, toxic gas, particulates, increased risk of respiratory problem and cancer. CXHY, or solid carbon. Methane, higher level of methane leading to increased global warming, which leads to a climate change. Oxides of nitrogen, acid rain, photochemical smog, and respiratory problems. Sulfur dioxide, acid rain. Describe how the greenhouse gases, carbon dioxide and methane cause global warming limited to the absorption. Carbon dioxide absorbed by the UV rays, then reflect it back and emit and increasing the heat energy. So these three processes are very important to explain in context of greenhouse gases. So that's why carbon dioxide leading to increase the global warming. Reducing thermal energy loss to space. So this thermal energy, which emit thermal energy that loss in the space. State and explain strategies to reduce the effect of these environmental issues limited to climate change. Planting trees, this is very important. This is addition in this year. Climate change, planting trees, how to reduce these environmental issues limited to climate change. Planting tree, plants more trees, reduction in livestock farming, decreased use of fossil fuels, increasing use of hydrogen and renewable energy, wind and solar. Acid rain, how to uh, eliminate acid rain, use of catalytic converter in vehicles, reducing emission of sulfur dioxide by using low sulfur fuels and flue gas desulfurization. This is very important with calcium oxide, desulfurization with calcium oxide. So in catalytic converter and desulfurization with calcium oxide can be possible and calcium carbonate as well, but he asked you that with calcium oxide, so use calcium oxide. So calcium oxide like sulfur dioxide plus calcium oxide, so this is used calcium sulfite, which is further oxidized to form calcium sulfate, further oxidized to form calcium sulfate. So this is desulfurization, only sulfur dioxide, desulfurization with calcium oxide. Similarly, nitrogen dioxide also desulfurized calcium nitrite, NO2 twice, and calcium nitrite further oxidized to form calcium nitrate. Explain how oxides of nitrogen form in car engines and describe their removal of incomplete combustion of fuel in car engine produces nitrogen monoxide and carbon monoxide. So this is reduced in catalytic converter and convert into less harmful gases like carbon dioxide and nitrogen by using in catalytic converter. This reaction is very important. Please learn this reaction, and in the presence of platinum and palladium. Describe photosynthesis as a reaction between carbon dioxide. Photosynthesis reaction is carbon dioxide plus water to form C6H12O6 to form 6O2. 6 water, 6 carbon dioxide. So this is photosynthesis reaction. And produce glucose and oxygen in the presence of chlorophyll. This is the condition, and using energy from the sunlight in the presence of sunlight and green part of the plants. Chlorophyll is the main source of main condition, and chlorophyll green coloring metal which is known as chlorophyll, and sunlight in the presence of sunlight carbon dioxide react with water to form glucose and oxygen. State the word equation and symbol equation for photosynthesis. Word equation is carbon dioxide, water, glucose, this is glucose, and oxygen, this is word equation. Carbon dioxide plus water. So this is all about the air. Now state the structural formula is an unambiguous description of the way the atoms in a molecule are arranged. including CH2, CH2, CH3, CH2. This is not a structural formula. Draw and interpret the displayed formula of a molecule to show all the atoms and all the bonds, like this CH2, like this. This is structural, full structural formula H, and similarly CH3, CH2, OH. This is the fully displayed structure. So just draw like this, and ethanoic acid like this, H, H, C double bond O. This is carboxylic acid. This is ethene. This is alcohol, ethanol. This is ethanoic acid, ethanoic acid, and this is ethene. And write the interpret general formula compounds in the same homologous series limited to alkanes, alkenes. This is seen. This is very important to learn. Please learn these formulas. Define structural isomers as compound. This is a definition of structural isomers with the same molecular formula but different structural formula, including CH4. This is the required C4H10, ethane, then ethene, butene, sorry, and then this is 1 butene and this is 2 butene. This is 1 butene and this is 2 butene. So these are required. The isomers of butane, 1 butene and 2 butenes are required. Identify a functional group as an atom or group of atoms. This is the functional group definition. Group of atoms that determine the chemical properties of homologous series. Describe the general characteristic of homologous series as having the same functional group. These are the characteristic properties, and this is very important: having the same functional group, having the same general formula, different from one member to the next by a CH2 unit, displaying a trend in physical properties. Physical properties are gradually increased except flammability and volatility, which are decreased down the sharing similar chemical properties. So these are the examiner commonly asks you to write down two characteristic feature. So just write down these two features. This is very important because it's simple and easy to learn. They have same functional group, same general formula, and just write down same chemical properties. But if you write down different chemical properties, then different from one member to the another by CH2 unit. Okay, write down whole, but instead of writing this, please, easy to learn. These other properties are easy to learn, so write down these. This, and this one, chemical properties. State that a saturated compound has a molecules which all carbon to carbon single bond. This is definition of saturated compounds. Please learn as it is. State that unsaturated compound has a molecule in which one or more carbon to carbon bonds are not single bonds, double bonds. You can write down are double bond, carbon to carbon double bond. Naming organic compounds. Name and draw the structural and displayed formula of unbranched alkanes. Alkenes including but1ene and but2ene. Propane 1-ol, propane 2-ol, butane 1-ol, butane 2-ol. This is propane 1-ol. This is propane 1-ol. And this is propane 2-ol. O, second carbon having OH group. H, H, and H. This is propane 2-ol. This is propane 1-ol. Hopefully to understand. And butane 1-ol. H, 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 H. This is butane 1-ol and this is butane 2-ol. This is butanol, and this is butanol. Now, carboxylic acid, the products of the reaction stated in section 14 point reaction with the metal like magnesium and calcium sodium, or metal carbonate like sodium carbonate plus carboxylic acid CH3COOH, and magnesium like CH3COOH. This is reaction of metal with ethanoic acid, CO twice, magnesium plus H2, and place 2 over here, and this is sodium CH3COOH to form CH3COONA plus H2, place 2 over here, 2 over here, and 2 over here. This is metal with ethanoic acid, and with all other carboxylic acid, the same reaction, same balancing. Similarly, metal carbonate with metal carbonate like sodium carbonate plus CH3COOH to form CH3COONA plus water plus CO2, 2, 2, and it is balanced now. So the products of the reaction stated in reaction, and sodium hydroxide, metal hydroxide, alkali plus acid, C2H5, this is propanoic acid I have written for you. This is sodium propanoate, C2H5COONA plus water plus water. Okay, so the products of the reaction stated in 11.4 and 11.7. Where is 11.4? Over here, in the ladder separately. It is explained in separate. So this is state the type of compounds present given the chemical name ending at ane is alkene, all, oic acid for carboxylic acid to form molecular structure displayed. Name and draw the displayed formula of the unbranched esters, which can be made from unbranched alcohols. Carboxylic acid is containing up to 4 carbon atoms. Fuels, name the fossil fuels: coal, natural gas, and petroleum. Name the methane as the main constituent of natural gas. State the hydrocarbon as a compound that contain hydrogen and carbon only. State the petroleum is a mixture of hydrocarbons. Describe the separation of petroleum into useful fraction by fractional distillation. This is a very common question, important. Please learn this topic by heart. Fractional distillation. How the properties of fractions obtained from petroleum change from the bottom to the top. At the top, the liquid fraction with lower boiling point distilled over. At the bottom, the liquid with higher boiling point will distill over. Name the uses of fractions. Refinery gas fraction at the top, and this is used in cooking, heating, and cooking. And decrease chain column limited to decreased chain length top at the top, higher volatility at the top, lower boiling point at the top, and lower viscosity at the top, which has less carbon atom. And as the length of carbon chain increased, become less volatile, compound become less volatile, higher boiling point, and higher viscosity. Name the use of fractions which are obtained from the fractional distillation. This is at the top, number 1, and refinery gases. for gas used in the heating and cooking. Second is gasoline petrol fraction for fuel used in cars. Naphtha fraction as a chemical feedstock. This is third. And kerosene paraffin fraction jet for jet fuel. Diesel oil gas oil fraction for fuel used in diesel engines. Fuel oil fractions for fuel used in ships and home heating systems. Fuel oil lubricating oil diesel and this is the a new addition, fuel oil fractions for fuel used in ships and home heating systems. Lubricating oil fractions for lubricants, waxes and polishes. These are the uses. Please, this is very important. Please learn by heart in this sequence. 6, 7 and 8, and bitumen fractions for making roads. So these are uses and fraction, very important. Alkanes state that bonding in alkane is single covalent bond, and alkanes are saturated because carbon to carbon single bond. Describe properties of alkane as being generally unreactive except in terms of combustion. In combustion, complete combustion, carbon dioxide and water, and incomplete combustion they like CH4 O2 to form carbon dioxide. Incomplete combustion, carbon monoxide and water. State that in substitution reaction one atom or group of atom is replaced by another atom or group of atoms like CH4 plus Cl2 UV light, so CH3Cl plus HCl. So this reaction is continue until unless all hydrogen are replaced by chlorine atom. 1 mole of chlorine replaced only one hydrogen. Please keep it in mind. Describe the substitution reaction of alkanes with chlorine as a photochemical reaction. Photochemical because it is present in light with ultraviolet. So this is photochemical. Sometimes examiner commonly asks you that define photochemical reaction. The reaction which takes place in the presence of sunlight, that is known as photochemical reaction. Activation energy, light providing the activation energy, and draw the structure and displayed formula of the products limited to the mono substitution. This is the mono substitution. So this is the mono substitution displayed structure Cl. Alkenes state that the bonding of alkenes includes a double carbon to carbon double bond, and that alkenes are unsaturated hydrocarbons. Describe manufacture of alkenes and hydrogen by the cracking of large alkane using a high temperature and a catalyst, aluminum oxide and silica. And other condition, this is one condition, catalyst, absence of air and high temperature. Just write down high temperature, no need to mention the temperature. So this is absence of air and high temperature. Describe this is the reactions, for example C8H18 to form C2H4. This is alkene and this is C6H14. This is hexane, this is ethene. And if C2H6, this is ethene, C2H4 plus H2. This is hydrogen is also, this is cracking and this is condition. Describe, distinguish between saturated and unsaturated. Saturated are alkanes, unsaturated are alkenes by the reaction with aqueous bromine. Bromine decolorize unsaturated alkene. Alkenes decolorize the bromine water. Bromine color is orange and the color change with alkene is orange or brown to colorless. And with saturated alkane or alkane, no change with alkane. State that in an addition reaction only one product is formed. Describe, for example, there are different types of addition: hydrogenation, hydration. Addition reactions, there are different types of addition reaction. This is bromination. For example, C2H4 plus Br2. The reaction is C2H4 Br2. C2H4 plus hydrogen to form C2H6, and nickel catalyst 200 degree centigrade temperature. So alcohols this is the fermentation of glucose, and these are the conditions: catalytic addition of steam to ethene at 300 degrees centigrade, 60 atmospheres. This is for this process. This is addition of steam, and 300 degrees centigrade one condition, 60 atmospheric other, and phosphoric acid used as a catalyst. So these are the two uses of ethanol solvent as a fuel. Describe carboxylic acid. I have discussed earlier about these reactions: metal, bases, and carbonates. And this is the describe the formation of ethanoic acid by oxidation of ethanol with acidified aqueous potassium magnate. This is the example of this acidified potassium magnate in the presence of heat. Oxygen is oxidized. This is oxidized too, and the observation is purple to colorless. Observation is purple to colorless. And this is C2H5OH plus O2. This is CH3COH plus water. This is second bacterial oxidation during vinegar production. Describe the reaction of a carboxylic acid with an alcohol using an acid catalyst form an ester. So, for example, concentrated acid is used as a catalyst for making ester. This is reversible reaction by using ethanol C2H5OH plus CH3COOH to form CH3CO C2H5 plus water. You know that H from this and OH from this eliminate to form water and concentrated sulfuric acid as a catalyst. This is a reversible reaction. Forward reaction is condensation. And backward reaction is hydrolysis. Backward reaction is hydrolysis. And the name of this ester is ethyl ethanoate. So names, you know that this is CH3COO C2H5. This part is known as ethyl, and this part is known as ethanoate. If you draw the structural formula of this compound, so just like draw like this. C ethanoate double bond O. This is 1 2, this is ethanoate. Now this part is ethyl C2H5. From O to this part, this is part of ethanol, and this part of acid. So this is known as ethyl, and this is ethanoate because 1 and 2 carbon. So this is ethanoate, ethyl ethanoate. So write down ethyl first, and this is ethyl ethanoate. Now polymers, define polymer as, this is the definition of polymers. Please, large molecule built up from many smaller molecules called monomers. Identify the repeat units or linkage in addition polymers and in condensation polymers. Reduce the structure or repeat unit of addition polymer given alkenes and vice versa. Deduce the structure of repeat unit of condensation polymer from a given monomer and vice versa. Polyamides from a dicarboxylic acid and diamine. This is nylon, and this is terylene. Describe the difference between addition and condensation polymers. State that plastic describe difference between addition and condensation polymer. Difference only one monomer is monomer. Same type of many monomers are used in addition polymer, uh, and it is the property of alkene. Condensation polymerization two are two different monomers like dicarboxylic acid and diamine form nylon along with water molecule plus water 2H2O and terylene with water molecules. Smaller molecules also. Condensation, different monomers join to form polymer and along with simple molecule. This is the definition of condensation. State that plastics are made from polymers. Ethene is to form polyethylene. This is C. This is the monomer of ethene. You know very well, and you have different examples. See, this is the polythene. Describe how the properties of plastics have implication for their disposal. Describe environmental challenges by plastic limited to the disposal in landfill sites. These are very important. You just learn these like by using these words. Disposal in landfill sites, accumulation in oceans, formation of toxic gases from burning. Describe and draw structure of nylon and polyamide. This is the structure of nylon. So, and this is the structure of PET polyethylene tetraphthalate is not required, name is not required. So polyester, one surrounding C double bond surrounding by two boxes and O surrounding by two. The monomer of this is dicarboxylic acid and diamine. So look at this, C double bond, C double bond. This is the this is the structure of nylon, and the linkage is amide, and the many linkages are polyamide, and this is linkage ester, and many linkages are polyester. Okay, the full name is not required. State that PET can be converted back into monomers and repolymerized. This is very important to learn. This is new addition in the syllabus, so you must learn this line that states that PET can be converted back into monomers and repolymerized. This polyester can be converted back because these two are reversible reaction, because backward reaction is hydrolysis. In backward reaction, compounds can be broken down into dicarboxylic acid and diol, and similarly this compound is also hydrolyzed to form dicarboxylic acid and amine diamine. So that's why converted into, so this is within this name, PET can be converted back into monomers and repolymerized. Describe protein as a natural polyamides and that they are formed from amino acid. This is the general formula of amino acid. This is using box. Okay, this is structural formula, general formula of amino acid. You should learn this formula where R represents the different types of side chain. Describe and draw the structure of protein like this. Look at this. This is the difference between amide linkage is same with terylene, but this is the difference between the nylon and amide. Look at here. C double bond C, but over here NH and then C double bond NH and then C double bond O. So please okay, experimental techniques and chemical analysis. Now, name operators for the measurement of time, temperature, mass, and volume. Stopwatch, thermometer, balance, burettes, volumetric pipettes, measuring cylinder, gas ring. Suggest advantages and disadvantages of experimental method and operators. Solvent as a substance that dissolves. It's very important. Just learn this. Solvent as a substance, that definition of solvent, definition of solute, definition of solution, definition of saturated solution, and definition of residue, definition of filtrate. Please learn these definitions. like this. Said like solvent as a substance that dissolves a solute as a substance that is dissolved in solvent, solution as a mixture of one or more solute dissolved in a solvent. So these definitions are very important. Residual substance that remains after evaporation, distillation, filtration, or any similar process. Acid-base titration, we have discussed earlier about the acid-base titration, burette volumetric pipette, suitable indicator, how to identify the endpoint of titration using an indicator. Chromatography, describe how paper chromatography is used to separate mixture of soluble substance using a suitable solvent. Describe the use of locating agent when separating mixture containing colorless substance. Knowledge of specific locating agent is not required. Name is not required, so don't worry about the name. Just write down the spray the locating agent after the experiment with colorless substance which makes colorless substance visible. Interpret simple chromatograms to identify unknown substances by comparison with known substance. Pure and impure substances. State and use of RF, distance traveled by the, this is the chromatogram. This is solvent front. Placed in beaker and covered with lid. This is lid. This is solvent front, baseline. This is solvent level and drawn with pencil. For example, this is a mixture. This is mixture like, and this is pure dye, red and blue. If red parallel to this, it means red is present. If blue is over here, it means blue is not present. If you ask to calculate the RF value, distance traveled by the substance, like this. If you ask to calculate the RF value of red, so the distance traveled by this divided by distance traveled by this. Okay. So in this way you calculate. This is distance traveled by the substance and this is distance traveled by the solvent. Separation and purification. Describe and explain methods of separation and purification using suitable solvent, filtration, crystallization, simple distillation. Simple distillation, two substances are separated. Like from copper sulfate solution, water is separated from copper sulfate solution. Water has higher boiling point, so distills over first, later leaving behind copper sulfate solid. Similarly, fractional distillation used for crude oil and for two liquids with different boiling point. Suggest suitable separation and purification techniques. Given information about the substance involved, identify substance. Please learn all these tests. All these tests: identification of ions and gases, and identification of ions and gases continued: lithium, sodium, potassium, calcium, barium. Flame test to identify the cations. चलो ये मैं की करनी है